So today we are going to discuss about few topics. Firstly, in this series, I would like to start quadratic functions. Quadratic functions. So the second topic would be exponential functions. Exponential functions. Third one would be logarithmic functions. Logarithmic functions. Then finally, I'm going to discuss about trigonometric functions. Trigonometric functions. So today I'm going to discuss about quadratic functions. So part 1, quadratic functions. So first of all, we will understand what is a quadratic function. So example would be like this. So here the highest power is 2. This is called highest power. Highest power is 2. So any function, any power function which has the highest power 2, they are called quadratic functions. Now if you think about x to the power 3, they are cubic functions. So quadratic functions, the maximum power should be, the highest power should be 2. Now if you think about this one, ax squared plus bx plus c. So now if you look at the x, the variable, so the maximum power is 2, the next one is 1, with c you have x raised to the power 0. So the lowest power would be 0, right? So this is called a quadratic function. So these are called coefficients, right? Coefficients. These are called coefficients. So what is a coefficient? So what is a coefficient? Coefficient is nothing but variable in front of a constant in front of a variable. Constant in front of a variable. Right? So for example, we can think fx is equal to fx or y, doesn't matter, is equal to 2x squared plus 5x plus 3. So 2, 5, 3, they are coefficients, right? So while we are dealing with these things, so we will understand that this x is called the dependent variable. It is called the dependent variable, and this y is called, sorry, other way around, independent variable here. This y is called the dependent variable. So fx and y is the same, right? It's another way of writing y, right? So f of x is dependent variable as well. So why this f of x way of writing a function is important, right? So let's understand this. Suppose you have y is equal to x squared plus x plus 1, right? Now if you look at this, you know this is a independent variable. Independent variable. Now this is a dependent variable. This is your dependent variable. Now this depends on This depends on x. This depends on x. However, that is not written. That is not written. So y depends on x. Y depends on x. That is not written. So to make sure or to convince that y depends on x, we are using a different notation, f of x. So this whole thing is your y. This whole thing is your y. But we explicitly tell that that depends on x. That means f of x depends on x. Depends on x. So that's the idea, right? Now, if you think about this example, think about this. F of p, g of q, f of a. So now all of these are dependent variables, but the letter inside this bracket tells you that depends on what. So depends on p. Depends on p. So for example, so f of p, now we are expecting in the right hand side, we are expecting something in terms of p. So similarly, if you write this one, we are expecting something in terms of q, like q plus 1 if it is linear. Here we are expecting something in terms of a, so a cube plus a squared plus a plus 1, something like that. So that's the idea. So here we are doing that. Okay, so now we know what is independent and dependent. So now what we are going to do is we are going to discuss more about quadratic functions or quadratic equations, right? So think about fx is equal to px squared plus qx plus r. This is a quadratic function. This is a quadratic function. Now in quadratic functions, we have an important thing called factorization. Okay, so factorization. So first of all, we will understand what is factorization. What is factorization? What is factorization? Now there is no, one-to-one definition to this one, but one can understand this. If it is asked to factorize, the first thing you have to look into is, if there are any common things, take them out, right? So take the common terms out. Common terms, or people call factors, out, right? Common factors you have to take out. Second one, so if you take the common factors out, or if you can't take the common factors out, then what is the next step? Try to simplify the function to a more simpler level. Simplify the function into a more simpler level. So these are the things we are going to do in factorization, right? So these are the things we are going to do factorization. Now what we are going to do is we are going to discuss some of the quadratic equations and how to factorize them, right? So factorize the following. So the first one, fx, or you can say y, is equal to x squared plus x. So here you need to factorize, right? So you need to factorize this one. So first thing is take the common things out. So what is common here? X squared means x times x plus x. So you can see. So what is common here? X and x common. So if you take x out, then you have this x remaining and this plus, and then here you have 1 which is invisible, and that is what you are going to have here. Now how do you make sure that your factorization is correct? So you can always double check by bracket multiplying the answer. So x times x is x squared, you are recovering that, and x times 1 would be x, and you are recovering that also. So that would be the answer to that question. Now if you think about this one, fx is equal to 4x squared plus 2x. Then you can see 2 is a common thing, x is common also, so you can take 2x out. So here you get 2x and plus 1. So this is what we call factorization. Okay, and then there is another way of doing this. Suppose you have x squared minus 1, and that is a quadratic 2. See, this is a quadratic 2. So now if you are asked to factorize, there is no common thing here. So what you are going to do is understand the pattern, the structure. This is difference of square. If you remember, difference of square, right? So the difference of square is x squared minus y squared can be written as x minus y, x plus y, x minus y, x plus y, and that is again factorization, right? So in this factorization, what you are doing is the second definition of the factorization. Second definition would be simplifying the statement into a more simpler level. So similarly, in the third example, you can use the difference of square. So x minus 1, x plus 1. So that would be the answer. Okay. Now, next question, question number 4. Suppose you have fx is equal to x squared plus 1. You need to factorize. You can't factorize. You have to leave x squared plus 1 as it is. Why? Because you don't have any common things to take out, or you don't have a way to simplify this into a more simpler level, right? So remember these patterns. But if you have fx is equal to x squared plus 5, not plus 5, x squared minus 5, then what we do is we write this one, x squared minus square root 5 square. So this is going to be now x minus square root 5 x plus square root 5. So this is again factorization. So what definition we used? We used the second definition. So the second definition would be simplifying the statement into a more simpler level. Okay, so now the big picture here, very important. Big picture, very important. So if you think about the quadratics, there are three types of quadratics. One-term quadratics, right? I would say one-term quadratics, and then two-term quadratics, and then the next one is three-term quadratics. Three-term quadratics. One-term quadratics examples like y is equal to 4x squared, y is equal to 1 divided by 2x squared. So it's one term. What do you mean by one term? So you can see here, it's just one term, x squared only. Now, what about the two term? Two term would be like y is equal to like x squared minus x, or y is equal to 4x squared plus 3x. Now you can see two variables are there, right? So two terms, right? The third one, that would be something like y is equal to 3x squared plus 2x plus 5, right? In general, y is equal to px squared plus qx plus r. So you can see now there are three terms here. Okay. Now we have discussed, so here in the first term there is nothing to factorize, right? Nothing to factorize. So what do you mean by factorize? Taking the common things out, or simplify the term into a more simpler level. Two-term quadratics. So how to factorize it? You can take the common things out, right? You can take common things out. Okay. Then secondly, you can use the difference of square. Difference of square. That's how you factorize the second term. Now the third term, that is what we are going to discuss now. There are two ways that you can factorize that. The first one would be the general method, the general bracket method. The second type would be completing the square method. Completing the square method. Now we will discuss the general bracket method first. So we are discussing three-term quadratics, right? So we are discussing three-term quadratics. So inside that, the general method. Okay, it's a general method. Okay. Now we will take example and try to understand this. The first example would be y is equal to x squared plus 5x plus 6 squared plus 5x plus 6. So now you need to factorize it. Okay, you need to factorize it. Now if you think about factorization, so what definition you are going to use? Not the first one, but the second definition. Why? Because if you look at this and this and that, there are no common terms, right? There are no common terms for those three terms, right? There is no common term for those three terms. So second definition, right? Second definition is used. Now second definition means what? Simplifying into a more simpler level. So now we'll see how to do that. First of all, what you do, you take the coefficient in front of x squared and then you multiply that with the constant term here, which is plus 6. So it's going to be, when you multiply that, right, so you're going to multiply those two, so it's going to be plus 6. Then what you're going to do is, you are going to make all possible common multiples of 6. So you can say 6 times 1, someone can say minus 6 times minus 1, one can say minus 3 times minus 2, one can say 3 times 2, right? So those are the all possible multiples. Now what you are going to do is, we are going to add those two terms. So 6 and 1 is going to be 7, the other one is minus 7, the other one is minus 5, the other one is 5. Then what you are going to do is, you are going to match the middle term here with the number you get here. So 5 and 5 you are going to match, right? So 5 and 5 you are going to match. Now let's do this. So your question is x squared plus 5x plus 6. Now you understand that this plus 5 is written as this way, right? Right. So from there we are going to get the plus term, right? Because 3 plus 2 is 5. How do you know 3 plus 2? You are taking that from here. Okay. So that is the strategy. So now what you are going to do, here you get x squared. Now plus 5 is replaced by 3 and 2. So it's going to be x squared plus 3x plus 2x plus 6. Okay. Then this bit is very important to understand. Okay. So I'm going to copy this one down here so that I have enough space. Okay, let's do that. So x squared plus 3x plus 2x plus 6. Now let's see these two terms. Then we'll see these two terms. The first term, what is common there? We are factorizing. Okay, we are factorizing means taking the common thing out first, right? So look at the first two terms, x squared and 3x. X is common. If you take x out, x is what remaining from x squared and plus 3. Then from the wiggly part, you are going to take 2 out. So when you take 2 out, you get x plus 3. Okay. So this step also factorization, right? This step also factorization. Okay. And the second step also factorization. Okay. So second step also factorization. Now you take this term here and this term over here. Now from those two terms you can see x plus 3 bracket. X plus 3 bracket is common, right? So you take x plus 3 out. So if you take x plus 3 out from here, what is remaining? X plus. If you take x plus 3 out from here, what is remaining? 2. Right? So that's the end of the game. Right? So what we have done, we obtained that x squared plus 5x plus 6 is equal to x plus 3 and x plus 2. Okay. So this is before factorizing. Before factorizing. This is after factorizing. After factorizing. Okay, so that's the end of this part. In the next part, I will teach you how to do the completing the square method. Until then, see you.